So one of the things that you need to be able to do is to read analog meters. And in this day and age, everybody's used to reading digital meters. It just tells you what the speed limit is or how fast your car is going. But in certain cases, you've got an old analog meter that you have to be able to read and interpret. So how do you do that? Well, it's actually pretty easy when you think about it. There's hash marks that are corresponding to the right amount of power that you would read and give the answer for. Of course, you want to know what the scale is. So on this particular meter, the very top is 100 kilowatts, all right? And you'll notice that as you read along, it goes from 5 to 10 to 20 to 30 and so forth. And say between 30 and 40, and likewise between 40 and 50 and 50 and 60, there's actually 4 marks that are evenly distributed. There's one exactly between 20 and 30. There's one exactly between 30 and 40, etc. So you're going to make the assumption, and this would be correct, that the mark halfway between 30 and 40 is 35, and halfway between, say, 50 and 60 is 55. All right, no more to it than that. However, if you look a little bit more carefully, you'll see that there's actually 4 marks, as I mentioned. So between the one end, say 20 and 30, there's the middle one. There's another one between 20 and the halfway mark. So there again, you can assume that that's also half. So the middle one between 20 and 30 being 25, and the one between 20 and the first mark up, so first out of 4, that is going to be 2,500. So it's 1/4 of 10,000. And it goes the same all the way up. Major hash mark, 40, 50, 60, etc. One level down is halfway mark, so say 15, 25, 35, 45, etc. And even between 20 and 25, there's a middle one, 22.5 is what that would be. One important thing to consider with these meters is there's a limited amount of accuracy, and typically the accuracy is no more than 2% of full scale. That's 2 kilowatts in this particular meter. You can't resolve down to below 2,000 watts at the very minimum. This meter is a little odd in that sense because the hash marks are actually 2,500 watts. So with this particular meter, I would say don't ever try to get better accuracy than 2,500 watts because that's the minimum division. So sometimes on a transmitter you have what's called a multimeter, and what that is a meter with multiple scales. Remember on the power meter I said you had to know what the top scale was, and I said it was 100 kilowatts. This particular meter, on the top scale is 10, and on the bottom top scale is 3. So you'll notice here there is a switch that allows you to read different things. Each time it tells you what scale to use. So the top one is 0 to 10, this one's also 0 to 10, this one's 0 to 30, which means you take this reading and multiply it by 10. Same with this one, and 0 to 100 would be the top scale, and you'd multiply everything by 10 in that case. The very bottom one, 0 to 300, so you'd read this scale and you'd multiply by 100. We're going to turn this thing on and I will read you what the power is. First power setting, 5 kilowatts. Right there at 5. Second power setting, 10 kilowatts, right there on 10. Third power setting, 20 kilowatts. So I'll give you an example of this one while we're at it. So here we're reading PA voltage DC. This is reading 2.4. So I multiply it times 10. Answer is 240. Let's see, another example. Minus 8 volts DC. Okay, this is the 0 to 10 volt scale. So this is 8.8. It's actually minus 8.8, but yeah. Let's see, another example. This one, 0 to 30. So I read the bottom scale, multiply by 10. That would be 2.45 times 10, so 24.5.